In the context of electricity, DC and AC could be referred to current or voltage. Let's start with the direct current. The direct current is a current having one direction. Look at figure 1. The direction of the current is counterclockwise. This current has one direction, so it is a direct current. The direct current could be sent by dry cells, lead acid batteries, DC generators, or DC power supplies.
We have many types of direct current. If the direct current has a constant value, then this current is said to be constant or steady direct current. Look at the figure. We have three curves. The first one is a pulsating direct current, and the purple one is said to be a constant direct current, and the third one is said to be a rectified direct current.
Direct current is almost exclusively used in any low voltage device. Cell phones and laptops, for example, rely on direct current. They are plugged into the wall with an AC adapter, which is a device that converts alternating current to direct current.
Also, in TVs and radios, AC is converted inside the device into DC. That means an AC adapter placed inside these devices and converts the AC voltage into DC voltage. All devices that use a USB cable for power rely on DC.
Let's move to the alternating current. The alternating current is a variable current that changes direction periodically. Here we have 3 points. The current has a variable size or value. The current changes direction, and the current changes direction during a constant time interval. Let me give you an example. This is an alternating triangular current. Look at the triangular shape of this current. As you see, this current doesn't have a constant size or value. Its value varies between -6 and 6. The maximum value of this current is 6 amperes. The time needed by this current to repeat itself identically is 0.5 seconds. This is the time period of the current. And as you know, to calculate the frequency of this current, we need to divide 1 by the time period. So the frequency of this current is 2 Hz. Let me give you another example. The alternating sinusoidal current. Similarly, the maximum value of this current is 9 amperes. The period is 2.5 milliseconds, which is the time needed by this current to repeat itself identically. Finally, the frequency is 400 Hz.
The alternating current is produced by an AC generator, such as the alternator that converts mechanical energy into electrical energy, and the function generator or the signal generator. AC is used to deliver electrical power to houses, office buildings, factories, etc. This crocodile simulation shows the brightness of the lamp when connected to a DC and to AC source. In this experiment, the lamp is connected to a DC source. Let's start the simulation. This simulation shows that the current has one direction, which is clockwise, and the current has a constant value which equals to 833 milliamperes as shown in the graph below. Now observe the brightness of the lamp. The brightness of the lamp is constant. Now let's observe the brightness of the lamp when connected to AC source as shown in this experiment. Look at the direction of the current. We observe that the current has two directions, clockwise and anti-clockwise. Observe the reading of the ammeter. It varies approximately between 600 or minus 650 microamperes and plus 650 microamperes. Now let's observe the brightness of the lamp. Now the current approximately has a maximum value which is 653 microampere, so the brightness of the lamp is maximum. Now the current decreases with time. We observe that the brightness of the lamp also decreases with time, and now the current flows in the negative direction and has a maximum value, or approximately a maximum value, which is around minus 565 microampere, and the brightness of the lamp is maximum. So the current decreases to become approximately zero, and now the brightness of the lamp is zero, and so on.
Now let's discuss some advantages of DC over AC. DC can be stored in batteries, while AC cannot be stored directly in batteries. DC is more efficient for low power applications, while AC is not as efficient for low power applications. Let's move to some advantages of AC over DC. AC is less expensive to generate and transmit, while DC is more expensive to generate and transmit. AC is easy to transmit over long distances with low energy losses, while DC is difficult to transmit over long distances due to high energy losses. Because of that, current and voltage in our homes, factories, schools are AC. AC can be used to power high-power appliances and motors. DC is not recommended to be used to power high-power appliances and motors.